Welcome to the Digital Health Training Series. This is Foundation for Medical Professionals. Even though still people are joining in, I think we better start because it's been 4 minutes. Yes. So I'll first give some housekeeping rules for the session. I'll be starting the recording and this will be uploaded to YouTube later on. And please keep your mics muted and you will be allowed to unmute and ask questions at the end of the session. So the training will take 1 hour and 10 minutes. I'll try to minimize it to 1 hour. And there'll be 20 minutes of Q&A sessions. Please excuse me as there are more people joining in. I have to approve them. And I won't be giving textbook definitions because the session is mainly for healthcare workers who are new to IT, who wants to get started. Rather than I want to give a simpler meanings. And I will mention the sources wherever they are applicable. And the detailed descriptions will be given in the following lesson. So I might give a very simple description in this training. And some acronyms aren't explained to keep it simple. So for example, what does XML, JSON or FHIR stand for? You can always search, but I won't be giving these letters one by one to keep it simple and not to confuse you. And this record will be uploaded to YouTube for later on. So we have 32 people already. Yeah, we better start now. Okay. So about me, I'm Janak PS. I'm from Sri Lanka. I've been a software engineer since 2003 and currently I'm working as a team lead for a leading healthcare IT company for Norway. And I've done the HL7 FHIR certification last year. And my website is firetools.net, which is dedicated to teaching about one of these healthcare standards. So I'll be going through all of these things one by one and show you how you can benefit from the website. So before we start about this, let me explain about what this training series consists of. So this will have 6 sessions, and today's session is intended for the healthcare workers especially who are interested in digital health or who may have started to use a little bit of digital health and who wants to get some idea how software works and what happens behind the scenes. And the rest of the sessions are based on one particular healthcare data standard. So before everything, the HL7 FHIR could be totally new to you. The word HL7 is coming from an organization called Health Level 7, which is defining healthcare related data standards. And FHIR, we call it, even though this is FHIR, we pronounce it as FHIR. It is one of the latest healthcare data standards. And that's the main standard I want to focus this on. So from the second session, I'll be introducing you to 5 main healthcare data standards, namely V2, V3, CDA, OpenEHR, and FHIR. And I'll be comparing them, how they are different, and what you can do with each of these standards and the popularity of these standards along with the current state of it. From session 3 onwards, 3, 4, 5, and 6 are all about the FHIR standard and how you can go and use in daily life. Also about the value of this training, let me switch to a tab where there's a course from HL7 International itself. It's a foundation fundamentals course. And I just wanted to give an idea about the value of these trainings. For example, you will be charged $1,260 if you're a non-member, or there could be a country body, or your company could be a member, and at least you will be having to pay $500. So these kind of courses are quite expensive, and as a result, what I have seen is very less people are doing these kind of courses, and even though there are enough content on YouTube to be checked free of charge, the order of this content is very tricky. So we find people going through content which is not for the beginners, and they get even more confused. And that's the reason why I chose to do this free of charge and align this in a way that you can get some foundation before you get started, and have the topics one by one before you get confused. So let's get started with today's session. So these are the topics, and topics are categorized into explaining the digital health background and what it is for you and what it is for patients, and then how the software systems work and the problems around it, then how the technology is going to solve one of the main problems that we are going to identify, which is about this healthcare data standard. And then we are going to talk about some solutions that are out there currently in use, the future software solutions, and also some additional topics. So the first thing is, what are digital health software? And in normal use cases, we call them electronic health record system or EHR system. And I've taken some examples from EHR softwares that are out there. There are random examples. So if you are totally new to this, or you haven't had any use of software in your healthcare environments, these are just some examples. So you can see from the list, there are a list of appointments of patients and encounters. Then there are different views. And this is another one. This is listing a list of a calendar, an appointments list with links to prescriptions, orders, documents, and images, and also a list of medicines that has been given likewise. Then this one has a quite different view. It's a patient-centric one. It has a list of everything related to single patient, and appointments, the list of documents, and the immunization records. There we have alerts, problem lists, and so on. So the reason why I want to show you is to show that there are already lots of electronic EHR softwares that are out there. And for example, this one can be run on mobile, a laptop, and even a tab. And they are in different forms. And they had been developed for a long time, at least for 20 years. And they are already in use in hospitals and different care centers, labs, and so on. So the EHR software, so sometimes it could be electronic medical record systems. They are slightly different, but I'm refocusing on about EHRs in this case. So before we go on, there's a word called interoperability that comes in. So we need to have a simple idea about what interoperability means before we can go forward. So it simply means effective communication between systems in a meaningful manner. Here the communication between systems is what is important, also in a meaningful manner. There's no point if a communication happens if the meaning is not transferred to the other party. And that's the main thing about the word interoperability, and we will be hearing this word many times during this session and the sessions to follow. So when we say talking between systems, one computer system with the other, and they need to transfer some data between them. And this is the healthcare data that we are talking about. So if you see some of the data from the studies, this is done from Google about how healthcare software are making a difference in the healthcare industry. This says in average 4 hours per day it is wasted due to inefficient reporting reasons. And the word interoperability comes in here. It says 80% of the things are people have decided interoperability should be a clear priority. The exchange of data between systems should be a clear priority. And 90% say more personalized care is easy due to systems that are in place, and inefficient reporting wastes irreplaceable time. And that's what 92% think. So even though this was done in US, this is the situation globally. It says almost universally, physicians agree that they could provide more personalized care with increased operational efficiency. So the reason why I want to show how software is used is because the value that it adds in. And there's one big point when it comes to uh, how software is helping with the healthcare industry. And one question that some of you have is, will we get replaced by software? And that's a very valid question, because that is one of the reasons why some people don't even start learning about how healthcare and how technology works. My answer is no. And what I say is, instead of, your life will become easier and efficient, while both healthcare workers and patients will benefit. So this is not just for the patients, this is mainly for the healthcare workers as well, because your life will be easy and efficient with the use of software, because there will be enough things that you can focus on easily, because repeated actions and operations that can be easily given to software to be done. But having said that, if you don't adjust your skill set with the technological changes, you may get replaced in future with those who have adjusted. So that has to be said clearly, because this is a time where a lot of things are changing, and after about 10-15 years, you could find that technology has come a long way, and by that time, if you haven't updated yourself, then you could be at a risk. But I don't believe technology will ever replace a human being, because there's a lot that a human being will contribute. So first, why do we learn digital health? Although digital health has been there for many years, it is an area that is still being developed at a rapid speed as we speak. And the digital health technologies are or will be starting to be a part of daily life in healthcare. Therefore, the lack of knowledge can become a barrier to succeed in your career. And you could be, this is one of the important points to get, because you could be one of the few who learn the latest trends in digital healthcare. Because comparing to the other sectors, because we had been doing software for many years, there are sectors like finance, HR, distribution, manufacturing. Comparing to all these sectors, healthcare with technology is still being developed, and there's a lot that is going on. That's why I said it is still being developed at a rapid speed. So you could be one of the few who are learning certain things, and there aren't many people who know about this. So going forward, this Philips report by Philips says Future Health Index 2022. It says this year's report has shown that leaders believe increased training in digital health technologies will be the key to progress. Because if you look at the pandemic situations that came a couple of years back, we saw worldwide how a burnout of healthcare workers was there. So there was not enough healthcare workers, but there was more in demand. And this predicts by 2030, 15 million labor shortfall will be there. So one main thing we can do is to give some of the work to technology or devices or software, so you can take the burden is from the healthcare workers. And that's why the digital health comes in, and it can make your life easier first as a healthcare worker, and then the benefits will definitely come to the patients. Sorry. And the digital health ecosystem, or the health IT domain, and there are several parts of it. So we'll go through one by one to get some idea. In the e-health governance, it talks about how a patient can register as a patient in the government setting. Maybe there are national identity numbers or social security numbers, likewise, that has to be decided from a government level, or how they can be a part of the global healthcare systems. And this we already came across, the electronic health records, or EHR, and they are basically the software that runs on hospitals. Then there are two topics that is directly covered on this session, that is standards and interoperability. It's about how data transfers between systems, and we are going to talk about that. And I'm going to jump into this one called digital health literacy. Because without having the digital health literacy, it's very difficult to talk about these topics with people. Either you are a doctor, a nurse, or a software engineer. If you are to come up with a solution, this digital health literacy should be there. And going back, telehealth and telemedicine, again taking an example from the COVID-19, this is an area where telemedicine or doing consultations over a video call became very popular around the world. There are many countries who have taken that successfully, and that will be a part of the future. And when it comes to big data, it's basically analyzing large chunks of data to get insights to help in the healthcare. The importance of social networks cannot be underestimated, because that plays a huge role, because that's how we can reach people, and especially for the health promotions work. Then at last we have mHealth, that's a mobile related health. It could be a mobile device, or it could be a wearable, a smartwatch, or any device that people normally wear these days. Okay, so I taken an example from the Microsoft. So Microsoft has one called Microsoft Cloud for Healthcare. If you are new to the word cloud, just keep it for time being, because I'll be explaining about the word cloud and its structures later on in detail. I'll say simply this is a solution from Microsoft company about for the healthcare, and they are focusing on three main areas: enhancing the patient engagement, how the patients are engaging with the healthcare services, and empowering the team collaborations, because at a hospital you are working with a team to give healthcare, and improving the clinical and operational insights. The last one is quite important, because when in an environment where there's no software, these kind of insights are very rare to find, because it is very difficult to go through lots of data and find out some reports or generate predictions based on it, because the data itself is not in an electronic format. And that's one of the major areas that we are going to see in the future as more data are coming into the systems. And going forward with the system solution from Microsoft, keeping these three main sections inside, they have listed down how each of these sections are subcategorized into personalized care, patient insights about taken from the patient's history, virtual health, where telemedicine was one of these examples, but more than that, there are ways healthcare can be done virtually. And clinical and operational analytics, it's about analyzing large chunks of data again, as I said. Then the data interoperability. This topic we will be discussing in detail, what is the problem and what we are trying to solve here. And here about the continuous patient monitoring, it could be about devices that are plugged in, it could be a wearable, the data coming from it, and then the team collaborations and coordination. So that's how they have planned the solutions around their basics. So I taken another example from India, where they launched a telemedicine service back in 2020 with the start of the pandemic, and that has done 5 million consultations within the very first year alone. And this is the screenshot taken today with the number of hours of total consultations that they had done, and the doctors are attending right now at that moment, and the average time and the waiting times. So they are very interesting. The reason why I took this example from India is for a couple of reasons. Ones who are from United States or Europe, they might have had EHR systems or electronic health record systems for some time. So they could be quite familiar with these. But for most of the Asian countries, they are still starting up. So the reason why I took India is is listed down in the right corner. India is a huge country with a population of 1.4 billion people with diverse cultures with many languages, and which makes the environment quite difficult to launch nationwide. But still, this is a lot far more to be gone to reach the whole population. But they have done a good job in launching a new service in a much diverse environment. So if it can be started with a huge country like India, I think wherever you are from, it can be any of these systems can be launched. Yeah, I need to check the timing. Okay. So the global health market is predicted to grow almost 4 times from 2020 to 2027, whereas the software segment takes about one third of it, and there are services and mobile health sectors taking a good chunk of these market shares. And if you look at the global shares, we can see the North America and Europe has having a huge market share out of those. But still, the Asian countries, China and Australia, those are also coming up or trying to introduce or start with their operations. And there are some examples from China. This is not taken globally. This is 15 country average. And it says China is leading the way in adoption of digital health technology, whereas 90% of the healthcare professionals who currently use any digital health technology or mobile app, it's 94% versus 78% in a set of other 15 countries. And going along with the same, we have another stat from China says that 44% say they're likely to choose a remote consultation more than the 27% average from the other countries. Yeah, I'll be going through these slides quite quickly because most of you could be familiar with some systems, but this is mainly for the people who are totally new to digital health. Yeah, so let's take a simple scenario with COVID-19. So we have a case where there's an appointment and yeah, sorry, I was just checking the chat. Okay, so let me know if there are any voice or sound interruptions. Just unmute and tell it. I might not notice the chat. So going back to this COVID scenario, it's a very simple thing. We all have been through this. We take an appointment with the local vaccination center. Then when we go to the consultation with a doctor, they will check, doctor or a nurse, he will do a background check, and then we take the vaccine, whereas when we take the vaccination card. So where is digital health used in this scenario already? This is what we are going to see next. So this is a screenshot from the Apple website showing one of their health apps called Apple Health. And this shows here, right here, a COVID-19 vaccination card that you can find right inside this Apple Health app. And if you see the second screen, there are sections within Apple Health app that shows allergies, clinical vitals, and immunizations, lab results, and so on. And the point that I wanted to make was, if you might have realized there was a huge effort to make a digital certificate for COVID-19 vaccinations, just for that, because we didn't have one in most cases. But this example has been there from way before COVID came, because under immunizations, and if your state allowed the connectivity to the supported hospitals, you could anyway see any of the immunizations or vaccines that you have taken from the screen. So they didn't have to invent anything just to support the COVID-19 vaccinations as a digital format. Or they didn't have to come up with an app, try it out. No, that has been tried and tested, that has been already running. What happens is in this app, there are some supported hospitals in selected states in US, whereas the data is transferred from these hospitals into your app, and it could be several hospitals that they support. So you could go to different hospitals and take all the data into a single app and can see. So this is just a good example of how digital health has been solving daily problems which we are trying to solve right now in some countries. Now we want to find out who wants medical data. Before going through all these sections, let's see what medical data is, the types of medical data. We have reports, this is the most common one, manually written or printed reports, and images like X-ray or MRI scans, and it could be readings from machines or even wearable devices like smartwatches, or it can be even audio. There are dictations where a doctor would record the audio while doing an operation, or it could be a recording from a patient. So all these forms are types of medical data. And who are interested in it? So there are patients, obviously, and sports professionals, and they are the parts of end users. Then we have the medical professionals who are doctors, clinicians of all sorts of medical professionals, and researchers. Of course, the institutes, they are hospitals, primary care centers, and many such institutes are there. And of course, the policymakers. They could be public health administrators or politicians because they could be relying about these data to take some decisions. And it could be about ordering vaccines, it could be predictions coming from them, some precautions that they'll have to take likewise. So these are the different parties that are interested in medical data. So we have a challenge with sharing data. That's the main problem that we are going to solve and start learning through one of these. So the biggest problem in healthcare field is that about 80% of the medical data remains unstructured and untapped after it is created. So this is coming from HIT Consultants in 2019. And adding more to that, it says also, imagine with handwritten data added, the percentage of unstructured data can rise as much as 95%. So this is one of the biggest issues that we have before we move to a system. Because one can make a software, but the type of data we have is unstructured. So we have a huge problem in getting those unstructured data into a system in the first place. Because once the data is inside the system, there are many advantages or many things we can do. So I'll show some other aspects of digital health challenges in Europe, and also these are valid for the other countries as well. Starting with setup, scale, and governance of digital health services. To roll out in a country-wide scale, planning and everything will be challenging, especially in a large country like India. And communication and health workforce engagement and training. So this is one of these sessions. So the training has to be done on health workforce before they can start using it, and they should be familiar with it. And also there could be a resistance from within if they don't have a clear idea what it is trying to do. Then privacy and security concerns are there. For example, there are specific privacy data laws in Europe called GDPR, or in US there's one called HIPAA, and there are certain rules or regulations. They are very strict. So we have to adhere to those as well. Then tackling data fragmentation and interoperability. So we talked about data fragmentation, or the types of data that we have which is unstructured, and then another problem that we are going to talk about, the interoperability. Then sustainable financing and competing with other health systems and expenditures. So when there are more software systems coming in, there are of course competitions, but the competition should be healthy and there should be more collaboration between them if we are to succeed. And at last it says establishing and maintaining trust and relationships, because none of these things can be really put into practice if we don't have trust in both healthcare workers and the patients who use it, because this all depends on people's trust. So I want to show a history of the popular healthcare data standards that has been there. So from 1960s, it is said that the first known health system has been developed, but not a lot has been done for many decades. And it's 1989, this HL7, which is again a organization that is creating healthcare data standards. You can see that is being repeated quite several times. So they had been releasing several data standards to time, and around 2000, after 2010, there had been two standards that had taken more popularity. That is HL7's FHIR and OpenEHR. So we'll be talking about all of these such things in detail with a comparison in lesson 2. But I just wanted to give you an idea about what is out there and what are we going to talk about and why. So why have I chosen FHIR? One good example is from US. In 2020 December, the US government came up with regulations and decided that they have enough systems implementing on healthcare. I mean, there are enough software that is supporting as electronic health record systems. In order for them to communicate with each other, there should be a common standard. So they chose HL7 FHIR as the standard, and they made it as a regulation in late 2020. And by 2 to 3 years, they have given deadlines on what has to be done if you have to comply with the standard. You can read more from the details from ONC, or what you call as the Office of the National Coordinator for Health Information Technology. So US is the largest market in healthcare, where they had used healthcare IT for a long time, at least for more than 10 years. And even there was a stat saying even back in 2019, 95% of the hospitals were ready to use any of the data exchange methods, and that indirectly means they already had a software system running. They are very much in front. Europe is also starting up with certain things. They also had softwares. But when it comes to regulations, FHIR has given a lot of focus based because the regulations that has been introduced in United States. And that's the main reason why we are focusing on FHIR and how you can gain knowledge around it and what it can do in healthcare. So the getting started with HL7 FHIR is all about learning IT concepts as a foundation. If you don't do that, what happens is you might find certain things very tricky, or it could be these things can look quite complex. But in the actual world, when you start learning it one by one with the concepts, you can see how simpler they are. That's one of the reasons I didn't want to explain all the little details or explain the words of an acronym just to confuse you. So what is a system? And this could be too simple for some users who are already familiar with this, but I'm starting up with anyone who is not familiar. A system can be a computer like this, or a laptop, a wearable device, or a smartwatch, or even a device, a healthcare device, or even a mobile phone that can be running. So it's basically a combination of both hardware and software. That's what we call as a system. We need to have that understanding clearly before we can say what we mean by communication between systems. So why can't systems talk to each other? There we have 4 hospitals, and they are running different software systems. System A is running on hospital 1 and 4. B and C are different systems running on both. And only the communication can be done through hospital 1 and 4, because only they have the same system running. And the reason is there's a misconception between some people. Whenever there's a database involved, some people assume that the data between databases can be simply copied, but it is not the case. Even though it is a database, you cannot simply copy data between them. And if I give an example outside, if you take cars from 2 brands, And even though they might have similar features to drive, the speed, and everything, you cannot simply take one part of a car and replace the same in the other. And if you take two models from the same brand, still it's the same. And that's why we need some kind of integration, and before the systems can talk. So the system A can talk only with system A, and that's the problem we are trying to solve, starting with this healthcare data standards. Then how can systems communicate? Very simple thing, there should be ability to talk and use of a language and understanding the vocabulary. Whereas by talking, I mean the talk is defined by the HL7 FHIR standard, and the language is JSON or XML formats. Simply they are text files. And the vocabulary are various medical standards or medical terminologies, as we say. So when all these three are fulfilled, we can say two systems can talk with each other. The standards should be followed using the language, which is a text format, and using the predefined vocabularies. So let's look at what JSON and XML means and why. So the same information is represented in JSON and XML here. Here we have information about 3 employees. We can see name and age here. The only difference is the way it is written. The syntax is the only difference. You can see 3 employees are listed here. The same information, though it looked a bit cluttered, if you can see from one to the other, this is the same information that carries over here. So these are the two ways the same information can be represented. And why they are used is they are machine readable and they are text based. What I mean by machine readable is, if we are to tell the same information, I would say to a person, there are 3 employees named James, Jane, and Wesley with these ages. Then they can understand. But we are talking about two systems or softwares who are reading data from each other. So they have to have a proper format in order to understand what we are sending. That's why a format is needed. So these are the two formats that we normally use for data transfer. And we'll go through simple examples. Understanding XML elements, attributes, and values. So element are what we see as these: patient, name, prefix, and everything. And attribute is what we call as this date and time or code, which is in light blue. And value is the actual value that is contained within. So these are the main 3 elements of any data. And the way that it's written is the only difference. The same data can be either included as a part of an attribute, or it can be directly included as a part of the element. It's up to us to decide how to do that. You can see it is about a patient, name and family name is there. There are 2 given names, Marcus and Joshua, and there's a gender detail for male, and there's a birth info likewise. So let's look at how the same data looks in JSON. So we have the same data. It looks a bit different. It could be a bit lengthier, but it's exactly the same data. And one thing to notice here is, I will go back once more to the XML. You can see when the same type of data repeats, the same element name repeats in XML. In this particular case, they are not repeated. They are given one after the other with a comma separated array. Apart from that, there are no kind of attributes in JSON. I mean, it's all name and a value pair in wherever you go. Some call these objects, and we don't need to confuse with those words. So basically, this is the structure. So I'm only giving you an introduction. So it's up to you to just find out about JSON and XML and how they are used, the differences, and there's more to them. Especially in XML, there are different other ways how XML can be used. I'm giving very simple example. Okay, so we have it again up for comparisons if you need to have a look. we have the repeated sections, which is combined here. And at a glance, JSON looks clearer, but it's both are totally fine. XML has been there for a long time and JSON has come somewhat later, but they are used widely. Yes, so let's take a look at the data model. So if we are to represent health data, there should be a data model saying this is how we represent certain elements in healthcare. Let me quickly see there's a chat. Yeah, we'll go get back to questions at the very end. You can send them in, that's okay. So this is an example with a patient-centric data model where at the very middle we have the patient. There are some example units that are linked with the patient. We are starting with the practitioner who is doing that. Then encounters of the patient, the organization, that is the hospital, departments, sections and wards, and the immunizations, the vaccines. Then we have about medical administrations, about the administration side of this work, allergy intolerances, then the care team, the teams that is a part of the patient care, then the devices linked with it, procedures and so on. So this is just one example of a data model whereas the patient is the center. This is taken directly from the FHIR data model as a subset of the whole. In this example, we have 19 resources. By resources, what I mean is this one of these units, which you see in one box. And in some data models, they might be called as a class or an entity. Different words are used. In FHIR, these models are called resources. So they have defined 146 resources in healthcare to fully cover most of the things that you need to transfer or store about. So in this particular example, we see only 90. You can imagine when all the 146 resources are entities or put together, it can basically cover almost everything. But having said that, the FHIR standard is not going to be a perfect model to cover every single scenario out there. Because by definition, it covers only 80% of the scenarios. Because I will explain this situation more in the lesson 2. Because when they came up with different data models to represent data in healthcare, they have even tried to create a perfect model and they had failed. And as a result, they have decided, okay, we will cover 80% because in any case, there are exceptions or differences and there's no single globally agreeable data model that we all can use. There are always different cases and especially different attributes that even a single hospital chain would like to have. So 80% of the use cases are covered, where the rest 20% is up to for us to add it. And it is designed in a way that we can add more elements and proceed. Yes. So one point to get from here is the data model is mainly patient-centered because patient is the main core element. Okay. So checking the time. Yeah. And the FHIR model fits in. This is where the FHIR model fits in. So we had a look at what the types of data in medical, and these are the entities who are interested in medical data. And these are the electronic health record systems that has the data. So all these parties are dealing with these systems, and the way that these software are taken with these data is through the FHIR standard. There are many other standards. FHIR is what we are focusing here. Because since it is a global standard, none of these things, or documents, devices, or anything, they don't have to be designed specifically to suit system A or B or C, because their internal structures will be definitely different. But instead, what they do is they create data in XML or JSON format, as you saw earlier, that is as per the described methods in FHIR, and then simply they can transfer. then you don't really need to know where the data even comes from, because the same data that can come from a wearable device like a smartwatch or a report or an image can come in the same way, because once converted, they will have the same structure. So you don't really worry the type of data, because the data consistency is there. Then once we have FHIR implemented, then what happens is simply all these systems can talk with each other, because they know a common language, which is FHIR, and they know a vocabulary, the medical terminologies, and they know how to talk with a meaningful manner. Now systems A, B, and C and all can talk with each other. Then we have a new word coming up called API and REST API. Let's look at the image down here first. So the same example taken from a restaurant, the two people are going there, and then the waiter comes in with the menu. They checks the menu and they places an order through the waiter, and then the waiter goes to the kitchen, takes the pizza, and delivers the food to the user. So the waiter works as the middleman here, whereas kitchen is in one end and the user is in the other end. That is exactly the same what is happening in an API. Because software is at one end, you can just ignore the word term server here. You don't need to worry about it. This is software, and this is maybe the end user or a mobile app. So the mobile app to work with many softwares, they need to know the language to talk with the software. Again, we are going back to the same scenario. They need to know the language. They need to have a format to talk. Then should know the vocabulary. So all these things are standardized using an API. So the request is sent to an API in a standard way. The API directly contacts the server or the software and comes back with the data, and then the response is sent. So we can even connect many softwares or servers to the same API, but the end user or the mobile application in this case doesn't have to change the way that it sends the request or receives the response. That's the beauty of it. So they simply don't have to worry about how the API is going to talk with the other systems behind the scenes. So that is all about the API, and that's heavily used in software. And then we move to what is a REST API. So after using an API for a longer time to talk between end users or end devices with software servers, it became a fact that there is a common pattern in getting many things done. For example, if we go back to the restaurant example, the things that you can do with in a restaurant is either make an order, request for changes, or sometimes maybe cancel an order and pay money through the waiter. Those are the possible things that can be done. Similarly, in software, there are main possible things. For example, inserting data, updating, deleting, and searching for data. So, and all those things are what it has identified, and it has made a separate type of an API called a REST API. You don't have to worry about what all these letters mean. It will only confuse you. That's why I'm not telling this at all. So get this. So these are actually called HTTP methods. Again, just don't worry about this as of now. These are different ways an API can be called. So get is mainly for searching for a single record, or it can even come with multiple records. Post is for saving data. Put is for again saving data for just for updates. Put and patch, those are for updates, and delete is for deleting data. So if you follow the REST API, again, these everything with data saving and updating can be done easily. And that's about REST API. And there are many technical topics you can read through about it. Then I'll go back to one practical example app using FHIR. Yeah. So this is one from the app gallery. There's a app gallery in one of these smarthealthit.org website. So this app is a growth chart. I had selected one patient before coming here. So the patient details are here, 9 years and 3 months old. So you can see, click on these things and see interactively how data points are with different data, and maybe there are some unit of measure changes from kilogram to centimeters to pounds and feet, so on. Or you can see a subset of these data as you wish with the first 6 months, 0 to 2, or the full life cycle. So this is a very simple app. The reason why I showed you is this is nothing much. This is only about the growth chart, or the how the weight has been progressing over a lifetime. The data that comes to this app is coming through the FHIR standard. And in this app gallery, they have many example apps which are reading from patients who are linked, or of course they are sample patients, and the data could be coming from different hospitals. So it doesn't really matter for the application where the data comes from, as far as the data is in the same standard. So as far as they are XML or JSON formats, and as per the FHIR standard, that's all the system wants to know. So if you can think what an API does and what a standard does, this is how it becomes easy. So the app doesn't really have to worry which hospital is sending data, so that you have to do any changes just for this. And then go back to this. Okay. Yeah. So there are more solutions that could be very popular in the future. Although these are available right now, in Microsoft they have already a demo for this. I have included and may label it under future because these are not popularly in use because they are just coming up. If you remember, we said that one big issue with healthcare data is because they are unstructured, and they are might be handwritten, maybe they are in printouts, but they are not in a structured way. There is nothing wrong with the healthcare workers, but that's how it is. So in this particular case, which called Text Analytics for Health from Microsoft solution, so we can input an unstructured clinical document. As you see here, the details are not clear. So in the second step, what it does is it identifies automatically the sections of this document. So these sections are highlighted, and then under each section, it identifies each of these words and categorizes them into name value pairs or medical codings or domains. So the data extraction happens here. Entity name recognitions linking to coding. There are specific medical codings that are used. Relation extractions, because there could be relationships between the data that you mentioned here from between the sections. And then you convert these data into a format that can be transferred. A FHIR JSON output is given here. The same data is converted into a FHIR. Then this same data can be easily transferred. So this is a very cool example from Text Analytics from Microsoft. And there's another one I want to show you. This is even better. This is basically asking the question verbally. In this particular example, I have given the link down here. You can check it yourself. It's a video where he verbally asks this question. Show me all MRI images of patients who were involved in this diabetes trial and had a sign of dementia or other brain disorders and did not take insulin. So he presses this icon and asks this question verbally. And what happens is, to this particular system, they had given an input, many of these imaging studies from MRI scans, and asking this question verbally, it is able to identify the question, break it down, search using the system, and present it in a way that, as you can see here. So as per the author or the speaker of this session itself, he says this is a very complex search operation. To a human being, this could be easily understood. I mean, anyone can understand the question. It's not a big deal. But if there was no system, even though we understand the question, where are we going to fetch data from? That is the biggest issue. We may have these MRI scans on film or paper, which is not searchable. We can never do a search or a research using that. Or we should have some summarized data somewhere. Then manual work has to be done if we are to come up with a result like this. That is the beauty of it. So let's go and see what happens behind the scenes. So this is actually a solution from voice to text using the FHIR APIs. Now some of the keywords that we had gone through has come up. So the voice input search is taken here, and it is converted to voice to text first, and then the text is processed and segmented to divide the question. So if we look at the question back again, show me all MRI images. So he wants to see MRI images of patients who are involved in this diabetes trial. So this is the second part. So only about the patients who are involved in this trial. And then who had a sign of dementia or other brain disorders. So these are the medical conditions they are interested, plus who did not take insulin. So these are the segmentations of the question. So then the text processing is done, which is called natural language processing, or which is a part of an AI. And then what happens is the search query is formulated and sent to a MRI image, searching the MRI image data. And that search query or search request is sent through a FHIR API. So FHIR is the standard, API is the way we talk with the system. So this is how we communicate. And then it comes back with a set of images and there are summaries giving the data. So this is a very cool example which will be a part of the future, what we are talking about. So now we are going to the additional topics. We have covered the main session topics now. The reason why I wanted to include about cloud solutions is the word cloud, as I said earlier, will be explained here in detail what exactly is meant by the word cloud in IT, because that is very commonly heard nowadays. We might not understand what cloud means, and more than that, the importance of using cloud solutions in healthcare. So the three examples that I have given here are from Microsoft, Amazon, and Google. These are the three main players in technological scenario when it comes to cloud solutions. And they are the three biggest companies in the cloud arena. And there are many other cloud softwares or the providers, but I have taken these three as examples. So Microsoft has what they call as cloud for healthcare. Then AWS, which is Amazon Web Services, AWS Healthcare is there. Then Google Cloud Platform has what they call a Cloud Healthcare API. Again, notice the word API coming up here. So let's look at some of the examples. So actually, where is the EHR software installed? It could be a desktop computer, a laptop, or a server. Server is basically a high-powered computer with a database. Think of it as a high-powered computer. You don't need to worry too much about it. Or on the internet. Again, what makes internet, it is a separate set of computers who are connected through each other through a network. It's simply that. So how is cloud coming into play? And there are three models of how software can be installed. And this can sound like Greek to someone who has never heard of this. So that's fine. IaaS, PaaS, and SaaS, these are three models how we can install. Infrastructure as a service, platform as a service, and software as a service, what it stands for. So let's look at a very simple example to understand what these models are. So this is again what we are going to learn is how a software can be installed, because I hear time to time from people saying they expect a software to be installed on their laptop to be used, but it's not the case nowadays because of thanks to the cloud. So about a car solution, if you own a car, you have to do all these things yourself. You have to choose what car to buy, pay for the car, pay insurance, taxes, maintain the car, choose where to park, pay for it, do the driving yourself, decide when to go, where to go, and pay for the taxes, which pay for the distance, which is fuel cost. So everything is in control and everything you have to do yourself. Then we go to the lease car option. where we don't have to maintain the car, but everything from top here, from parking to paying, everything we have to do ourselves. But we are not maintaining, insurance, buying anything, because we are just getting someone else's car for an agreement and using it. Then we move to a taxi where we don't have to worry about driving. We decide where to go, when to go, and pay for the distance. And if you move to a bus, we don't really decide, we decide where to go because we choose a bus, but we cannot decide where the bus has to stop and start because there are predefined routes. Instead, what we do is we choose a bus on a part of a trip where we go to from A to B. So there are many things that we don't have to worry about. We just pay for the distance traveled and we hop and hop off wherever we want. So I'll take another example to so these four solutions are mapped with infrastructure as a service, platform as a service, and software as a service. So still you might not be clear about what I'm talking about. And apart from these three solutions, there's a one called on-premises solution, which is you handling everything. So again, we go to another example with pizza. Pizza, whether it's made at home, take and bake, delivered, or dined out. In this made at home scenario, you do everything yourself, from finding cheese, toppings, tomato, making the fire, oven, everything you have to do, even till you are eating. So then you go one step further, which is called, this is on-premises solution. Then we go to the infrastructure as a service. Then we take and bake. We take a pre-cooked kind of a pizza, we heat it, and then we consume it. Then we go one step further, platform as a service, where we take further more steps off. Then we only consume it because we don't have to worry about everything else because pizza is cooked and delivered. And then we dine out. Then we only have to consume and we decide where to go and which one to buy, and we just consume it because we are not worrying about even the dining table because everything is arranged for us. So these are the three models in a software world. So let's map the same into software world. So these things can confuse you a bit. I'll try to explain very simply. So these are the elements of a cloud system, or not even a cloud system, in any structure before a software can be installed and used. There should be networking. It could be devices, wiring, networks set up in place, storage, that could be disks, hard disk or whatever. Then there should be servers, high-powered machines to run. Virtualization, you can forget for the time being. It's a way of separating servers and giving access to many. Then the operating system, you have heard about it. It could be Windows, Linux, Ubuntu, Mac OS likewise. Then all these, there are two types of software called middleware and runtime, and you don't have to worry at this stage. Then we have the actual software, which is the software itself and the data. And when we say on-premises, you manage every single thing yourself. The good side of it is you have single control of every single step. But the bad side is there's way too many things to manage. And whatever happens, then there should be dedicated staff who are trained at managing different things. So in an infrastructure as a service, you manage only these things from the operating system to the software that runs on it. But everything, the servers, the networking and the storage, this is taken as a service. So you pay for the service, whatever happens, for example, the connectivity is guaranteed 100% uptime, then the provider will have the warranty to make sure that the connectivity is there. You don't have to worry about that. Then the next way of delivering software through platform as a service, where you manage only the application and the data. You're not even worried about operating systems, getting the OS updates on time and getting any patches, virus plans or whatever. Everything is managed. And at last, in the software as a service model, You just use the software and you are not even worried about where the data is and how the application is or the software gets updates, everything. You just use the software and pay for everything. So the cost for all of these things can be different, whereas software as a service could be higher, but you have less control. Whereas when you have more control, you will have more things to worry about. So those are the options. And when it comes to cloud, we are basically talking about these three models: infrastructure, platform, and software as a service. The reason why I said about these things in detail is the healthcare software or EHR, they are moving into the cloud fast, although you might have used a software that is installed on your machine in an older fashion. That is changing quite fast, and I will show why. These are some examples of for software as a service. For example, if you are watching Netflix from a browser or watch YouTube, Facebook, anything, you don't install an application. You just go to the website and use it. And these are some of the other examples. You might not be familiar with these things unless you are a developer. Okay, since we are running out of time, I think we have come to the end of it. So I just want to end this with one of this. This I got from one of the sessions that I found from LinkedIn. It says, best time to do a cloud strategy was 5 years ago. And the second best time is right now. Basically says we are still far behind and cloud should be the main strategy for healthcare software, which is a message from the NHS in the UK. Okay, and I have given this report, which is quite lengthy. If you can have a look, that gives some of the trends and what leaders are thinking about the future of healthcare and also the present, how it has to change, where knowledge transferring and educating people around healthcare and health IT is one of the key factors that it has identified. Okay, think I have come to the end. Yes. So in a summary, we have talked about these topics or terms, and I've given very simple explanations. These are not definitions. We talked about digital health and the parts of it, what telehealth and telemedicine those mean. Then the word interoperability, effective communication between systems, then what big data does, analyzing data. Then the EHR systems, electronic health records, and then we talked about the HL7 organization, the FHIR standard. We just got an introduction about the FHIR standard, not in detail, and why it is used for, how it is used for, where. Then we at last talked about cloud systems and three different ways software can be installed on clouds. And then in the way we talked about the word API, which becomes a middleman between an end user or the software, and then the way we transfer data using XML and JSON. Okay, that's it. I think I was quite fast. Just wanted to finish it on time. Yes, you can unmute yourself or you can ask any of these questions. You can even send it through chat. I would love to just turn on the video and if you ask questions, that will be easier. Also, I'd love to just see who is there.
Yeah.
Let me see.
Uh,
Yeah, EHR and EMR, slightly two different systems. Electronic
Hi,
medical records. Mm,
hi, Chanika. I have a one question.
so
Like,
I'll switch. If there are any questions, I'll check the chat. Anyone can unmute and ask. While they
yeah.
do so, I'll go back to one of these things I wanted to show.
Hi,
So this is
Chanika.
the
I have a question.
health app example from the Apple website and what it does and the features and so on. This is about the growth chart sample application I showed you. Then Azure Healthcare, this is from Microsoft. Their solutions on healthcare and how they are doing new things that you could never do manually. There are many videos around it, and already the hospitals and entities who are using it. Then on Amazon, AWS for health, similarly they have solutions. So they have many areas which are supported, and their solutions are listed here. Then also the Google Cloud Platform with Google Healthcare API. And they have a series of videos, on demand videos listed here. You can watch one by one. They address very specific issues and show how the technology can be made use for your advantage. And a little bit about the site that I have made, firetools.net. And in that, I'll go from the beginning just to show. This is basically to help you learn about digital health, specifically FHIR, because that's the main area I'm working on. And here about learn video and tutorials, I am constantly updating this. So I have given some ideas for medical and software professionals because there are slightly different things, as I said here, where to start. So I'm coming up with a structure on how to start, and there are many topics to be covered. What we covered were kind of these two topics and some from here. I was quite quick, and I'm not sure whether I was too quick because I wanted to cover all
Yeah,
these things because there's a
yeah.
lot to read
Hi,
and mainly
hi,
there are many
Shanika.
videos to watch. I'll give the links and I'll send the PDF, the presentation to everyone who had attended. And there are some other links you can check from here. Okay.
Yeah, I have a question.
Mm,
Uh,
I'll wait for a few minutes
am I audible?
in case there are any of the questions coming up,
Hello,
or if you have
Uh,
any. If you even if you think
hello.
it's a
You're
stupid question,
audible.
that's okay. Just ask. Uh, Actually, you are helping someone else to learn because there's nothing called a stupid question.
oh,
Some doubt can be there because I'm especially targeting people who are not very much familiar with IT or software. So there are many things that you have no idea of, or I might have told certain words which is unfamiliar. That's fine. And if in case if you don't have any questions, you may leave, or I will stay on for like 10 more minutes for anyone to ask questions. And thank you everyone for attending the session. So I'll be posting on LinkedIn where
hi,
the
I have a
next
question.
when the next sessions will be
Uh,
scheduled. And let's hope to meet some of you further during the next 5 sessions. Thank you. You